this question is asking for the exact value. So, of course, you can use your calculator to find the round value of sine of 210 or cosine of 11 pi over 6. Actually, sine 210 will be an exact value, but in most cases, what you're going to get is a rounded value if you use a calculator. So, you have to know how to get the exact value in the format of square roots and fractions. Alright, to do that, you have to know a few things. The first thing is you have to know the graph of sine and cosine. So, first, the sine graph goes like this. You have 360, 180, 90, and 270. The sine graph goes 0, 1, 0, and then goes down to -1, goes up. Okay, so that's the sine graph. The cosine graph is the same, 360, 180, 90, 270, and then goes from 1, 0, -1, 0, 1. Okay, so that's the cosine of x. And then tangent of x is sine over cosine. Okay, so assuming that you know this, and hopefully you watched my video about knowing the values of sine and cosine is easy as 1, 2, 3, meaning that you have this coffee cup on a table picture. It's a coffee mug over a table. And the numbers that you fill in are easy as 1, 2, 3. 1, 2, 3. And the reason this is so important is because unless you're doing the 90 or 180 or 270 or 360, if you're doing those special angles between 0 to 90, then you have to draw these 3 sticks. So every quadrant, so here's from 0 to 90 degrees, it's quadrant 1, and then you have 90 to 180, which is quadrant 2, and then you quadrant 3 and quadrant 4, right? So from 90 to 180, for example, it's quadrant 2, right? Every quadrant will have 3 sticks. They are not evenly spaced. They're more closer, tight. They're tight into the middle. So there's a middle one, which is the 45-degree one, and then there's slightly before and after. Those are 30 and then 60. So you have to know that there's a 30, 45, 60-degree angles inside every quadrant. And the actual angle is, of course, 90 plus 30. So this first one will be 120. 90 plus 45 will be 135. 90 plus 60 will be 150. And the values, the lengths of these sticks are small, medium, or large. And you should know just by looking at the lengths which one is which, right? In this case, since it's going below the x-axis, it would be negatives. Okay, so using that convention, we're going to answer one by one. So first, 210 degrees. Let's see, go to 210 degrees. It's 30 degrees after 180, so it belongs to quadrant 3, right? What you want to do is you want to build 3 sticks. Okay, so middle one being the 45-degree one. Now you know that 30 plus 180 is 210. So you're looking at this one, right? Is that small or medium or large? Well, it's smaller than the other two. So this must be the small value. And since it's pointed downwards, it must be negative. So the answer is -1/2. Okay. The reason I'm writing down -1/2 is because square root of 1 is really 1. Square root of 1 is 1, so this is really 1/2. Okay, let's look at cosine 11 pi over 6. Remember that pi is 180 degrees. Right? And since a lot of you are not so familiar with this radian measure, it's probably beneficial to change everything to degrees. 180 divided by 6 is 30. 30 times 11 is 330 degrees. Now, what is 330 degrees cosine? Well, it's in the 4th quadrant, and 330 is 60 plus 270, right? So it's this one here, right here. And small, medium, large is the largest one of the three. So we take this radical 3 over 2, and since it's pointing upwards, it must be the positive radical 3 over 2. Okay, tangent 2 pi over 3. Let's rewrite the tangent as sine over cosine. So we'll always take this indirect approach when we are asked for the tangent. Okay, so tangent 2 pi over 3, you have to do sine over cosine, and then pi is 180. 180 divided by 3 is 60. 60 times 2 is 120. So if you change this radian measure into degrees, you get 120 degrees. And sine 120 degrees is right here, 3 sticks, okay? And it's 30 degrees away. 120 is 30 degrees plus 90, so we're looking at this one, the big stick, which is radical 3 over 2. On the other hand, 30 plus 90 is 120, so for the cosine, we were looking at the small stick. Also, it's going down, so it's minus, so it's minus 1 over 2. Now, you need to simplify this, so we're going to simplify it by multiplying 2 top and bottom, so you get radical 3 over negative 1. That's after multiplying by 2 top and bottom. Let me write that down. So it's multiply by 2, and then you get this, and then dividing by negative 1 is same as multiplying by negative 1, so that's the answer. Cosine 45 degrees, well, let's see. It's in the first quadrant, 1, 2, 3 sticks. 45 is the middle one, so it's the medium size. Okay, so we're going to get radical 2 over 2. That was simple. Cosine 7 pi over 4, well, pi is 180. 180 divided by 4 is 45 degrees, so this is 7 times 45 degrees, which is, let's see, 5 times 7 is 35, 4 times 7 is 28, so that's 315 degrees. Okay, now cosine 315. 315 is in the fourth quadrant, and it's the 45 degree one, it's the middle one. When your angle ends at 5, that's the 45 degree one. So again, we were looking at the medium size one, and it's going upwards, so it's the positive one. Okay, so this will be radical 2 over 2. Okay, let's continue. Sine 4 pi over 3. Well, this would be sine of pi is 180. 180 divided by 3 is 60, so it's 4 times 60 degrees. And then sine 4 times 60 is 240 degrees, right? Now let's go back to our previous picture. 240 degrees is 60 plus 180, so we're looking at this one, right? So we will be looking at the large one with, it's pointed downwards, so it's negative, so it must be the large value pointed downwards. Okay, now we have the cotangent, secant, and cosecant. Let's remember that cotangent is 1 over tangent, and secant is 1 over cosine, and cosecant is 1 over sine. Okay. So knowing this, cotangent is 1 over tangent, but since tangent is sine over cosine, the reciprocal of sine over cosine will be cosine over sine. Right? So it will be cosine over sine. And pi is 180. 180 divided by 3 is 60. So we get cosine 60 degrees over sine 60 degrees. Let's go back to our graph. Cosine 60 degrees is this one. Sine 60 degrees will be this one. So for the cosine, it's the smallest of the three, whereas sine is the largest of the three. So cosine is 1/2, and sine is radical 3 over 2. Okay. So it's going to be cosine will be 1/2, sine will be radical 3 over 2. Again, you multiply by 2 top and bottom. So you multiply by 2 top and bottom. And then it'll be 1 over radical 3, and then you multiply radical 3 top and bottom. And the reason you do that is because whenever you have a square root in the denominator, you want to multiply by that square root so that the denominator becomes an integer number. It becomes a whole number. Radical 3 times radical 3 is positive 3. Radical 3 times 1 is radical 3. And the reason for doing that is because in a lot of trig tables, or let's say you're doing a multiple choice question, sometimes you might not see 1 over radical 3 as a choice available, or you might not see this in the table, but this is what you want to see. And it's hard to know that these two are equivalent without knowing how to do rationalizing the denominator. If you use the calculator, you'll see that 1 divided by radical 3 will be exactly the same thing as radical 3 over 3. Okay, secant of pi over 6, this will be 1 over cosine of 30 degrees, because pi is 180. 180 divided by 6 is 30 degrees. And if you go back and look at the cosine 30 degrees, it's this one. It's the highest of the 3. It's the largest, so it's the radical 3 over 2. So it's 1 over radical 3 over 2. Now, this is really saying it's the reciprocal of radical 3 over 2. So reciprocal is 2 over radical 3. Or another way to think about it is you can multiply 2 top and bottom to get to that. Again, you want to rationalize the denominator by multiplying by radical 3 top and bottom. So that's what you get. Cosecant, this is 1 over sine of 225 degrees. And if you go back to the graph, 225 is exactly midpoint between 180 and 270. It's the medium-sized one that's pointed downwards, so it's negative. So it's 1 over negative radical 2 over 2. Again, 1 over means flip. There's a minus sign. So it's this. And finally, you multiply radical 2 top and bottom. You get 2 radical 2 over 2, but 2 and 2 cancels, and you get negative radical 2 as your answer. Now let's talk about the graph of a trig function, sine or cosine. When you have some number in front, the absolute value of that is called the amplitude. So the amplitude will be 4. And then the period and phase shift, there are formulas for this, but I advise you to just draw the graph first, and from there you can figure out the period. Alright, so how do we draw the graph? Well, first have to remember the sine graph. Sine graph is here. Since everything is in radians here, we should write the radian measure. So 360 degrees, 2 pi. Sine has the period of 2 pi. Half of 2 pi is pi. Half of pi is pi over 2. And if you take the midpoint between pi and 2 pi, you get it by adding the 2 and divide by 2. So it's 3 pi over 2, right? And now let's draw the graph. 0, 1, 0, negative 1, and 0. Okay, so it's like this. Okay. And this is 1. This is negative 1. Now the reason that I drew this is to show you that at 0, pi over 2, pi, 3 pi over 2, and 2 pi, sine has these special values, 0, 1, 0, negative 1, and 0. And knowing when this other graph will hit 0, 1, 0, negative 1, you can actually figure out exactly the points that this graph will pass through. Okay, so here's what I do. I take 3x minus pi over 4. I want to know when it hits 0. Well, 3x is equal to pi over 4 divided by 3. You get x equal to pi over 12. So I get one thing. Okay, and we found out that this point when sine becomes 0 happens when x is pi over 12 for this graph. Okay, so when you plug in x equals to pi over 12, then this entire thing will be 0, and you get sine of 0, which will give you 0 as the value. And that's how it works. Okay, and we continue on. We do 3x minus pi over 4. I want to know when it's equal to pi over 2. 3x, add pi over 4 to the other side. And since I want common denominators, I'll rewrite pi over 2 as 2 pi over 4, which gives you 3 pi over 4. And then dividing by 3 both sides, you're going to get x equals to pi over 4. Okay. And that's, again, it's good because when x is pi over 4, this entire thing will compute to pi over 2, and I know that sine of pi over 2 is 1. Then I need to know when 3x minus pi over 4 equals to pi. Add pi over 4 both sides. And again, same strategy. I'm going to rewrite pi as 4 pi over 4 so that they can be added to 5 pi over 4. Dividing by 3, you get x equal to 5 pi over 12. Okay. And then I want to know when 3x minus pi over 4 is equal to 3 pi over 4. Add pi over 4. And you get 3x equals to 4 pi over 4, but that's just pi, right? And then dividing by 3, you get pi over 3. Oh, sorry. I made a mistake here. I need to know when it's 3 pi over 2, right? Okay, so this is all invalid. Should be 6 over 4, and therefore 6 plus 1, that should be 7. I messed up. Okay, and then you divide by 3, you get 7 pi over 12. Okay. All right, and then finally, I want to know when 3x minus pi over 4 is equal to 2 pi. Add pi over 4 both sides. Rewrite 2 pi as 8 pi over 4, and 3x would be 9 pi over 4. Dividing by 3 both sides, you get x equals to 3 pi over 4. Okay. Now, you can draw the two periods of this graph by first drawing just the one period from what we obtained. See, pi is about 3, so 3 over 12 is 1/4. So let's just say that this is 1, and then it's 1/4 is over here. That's pi over 12. And then 3 pi over 4, pi is about 3. 3 times 3 is 9. 9 divided by 4 is 2.25. So if this is 3/4, will be somewhere here. Okay, so that's our 3 pi over 4, right? And then you need to draw all these other pictures. You know what? I think I made the one as too small. Let me do this again. Okay. So let's draw something large, very large. Okay, and let's just say this is 1. Then 1/4 of it is somewhere here. You don't have to be exact. It kind of helps if you know an estimate of these values. So 3 pi over 4 will be somewhere here. Okay. And then pi over 4 is the next number right after pi over 12, right? And then this is the next number and this number. And remember, these are evenly spaced. So what I want to do is I want to take the halfway between these two numbers. Ignore the 1 and 2. I'm just going to take the half somewhere here, which is 5 pi over 12. And the midpoint between these two is pi over 4. Midpoint between these two is 7 pi over 12. I'm just using the fact that all these numbers are evenly spaced. So in fact, another way to get these numbers is just solve the very first one and the last one, and you start calculating the midpoints. You get the midpoints just by adding the two numbers and dividing by 2, right? So that could have been a little faster. All right, anyways, what you do is you just draw this sine curve on this, because we know that at these values sine becomes 0, 1, 0, negative 1, and 0. Except that there's a 4 multiplied, so instead of 0, 1, it would be 0, 4. So the highest point will be 4, and the lowest value will be negative 4. Okay, and then since it said you need to draw 2 periods, you need to have another repeating numbers. And to know that, what you need to know is this length. Now this length here is what we call the period. And period is calculated by subtracting the first and the last, right? 3 pi over 4 minus pi over 12. And I need common denominator, so I want to rewrite the first one as 9 pi over 12 minus pi over 12, which is 8 pi over 12, and that's 2 pi over 3, right? So that's the period. And actually we now know the answer to B and C, so let's write them down. Period will be 2 pi over 3. Phase shift is the very first number that you get when you set it equal to 0, so that's pi over 12. And then to complete this, what you need to do is, since this length is 2 pi over 3, you need to draw the next period, which ends right here at 3 pi over 4 plus 2 pi over 3. Okay, and that's this is 9 pi over 12, and this is 8 pi over 12. So adding the 2, this will be 17 pi over 12. Okay, so remember, this is another 1 period, and therefore if you draw the sine curve from here and then until here, you get the 2 periods. And you just divide these into 4 equal parts. So just take the half of these two, take half of this, just plot those midpoints so you get evenly spaced, and just copy your sine curve again over here, and you're done. Okay. All right, let's do another one that's similar. Here you have negative 2, so the amplitude would be negative 2. Well, you can't say negative for the amplitude. Amplitude always has to be positive, so it's the absolute value of negative 2, so it's positive 2. And for the period and phase shift, we'll do that later. And then draw 2 periods of the graph of f of x. Okay. Now, what you do is you draw the graph of the cosine first. Remember, it's 2 pi, pi over 2, 3 pi over 2, and the graph starts from 1. The cosine starts from 1. Then negative 1 goes up. That's the cosine. Alright, and then there's something that you have to do extra because of this minus. The extra is that you need to know the graph of the negative cosine. So 2 pi, pi over 2, 3 pi over 2. And what you do is you take the negative, so instead of positive 1, you get negative 1, right? 0 is 0, negative 0 is 0, but negative 1 will become positive. So in other words, the graph will be flipped upside down. So it's going to be like this. Okay, so that's the graph of negative cosine x. Okay. And then you just need to know how to draw this graph with these numbers. So you'll get different ones. So we're going to have to figure out all these different numbers. Okay, so what do? We have to do 5x minus 2 pi over 3 equals to 0 or pi over 2 or pi or 3 pi over 2 2 pi, right? Now, if you add the 2 pi over 3, it will be 5x equal to 2 pi over 3 plus 0, or, well, you see, because 3 and 2 has the common denominator 6, we have to rewrite this as, first as 4 pi over 3, 4 pi over 6. So 2 pi over 3, if you multiply 2 top and bottom, you get 4 pi over 6. And pi over 2, if you multiply 3 top and bottom, you're going to get 3 pi over 6. Okay, and then 2 pi over 3 plus pi would be 3 pi over 3 to get common denominators. Again, you need 4 pi over 6, and if you multiply 2 top and bottom, no, 3 top and bottom, you get 9 pi over 6. And lastly, you get 2 pi over 3, and then 2 pi is same thing as 6 pi over 3. Okay. So you get 5x as equal to 2 pi over 3, or 7 pi over 6, or 5 pi over 3, or 13 pi over 6. And when you add the 2, that's 8 pi over 3. And finally, dividing by 5, you get the points that are important, which is if you divide by 5, you get 2 pi over 15, 7 pi over 5 times 6 is 30, 5 pi over 15, and then 13 pi over 30, and 8 pi over 15. Okay, so these are the 5 important points that corresponds to these 5 important points. Okay, so let's draw this graph. Okay, 15 is a rather large value, so let's see, pi is about 3. 3 divided by 15 is about 1/5, 2/5, this is 0.4. Okay, so if this is, say this is 1, 40% is like slightly less than 0.5. So let's just say this is 2 pi over 15. Now let's look at this one. 3 divided by 15 is 1 over 5, and 8 divided by 5 would be 1.6. Right, so it would be 1.6. So if this is 2, your number would be 8 pi over 15. Okay, and then the midpoint will be 5 pi over 15. That's like almost at 1, but slightly after 1. So it's 5 pi over, 5 pi over 15 is really pi over 3, right? Okay. So this is really, right. This is pi over 3. Okay, because 5 and 15 reduces. Alright, so pi over 3. And then you write the 7 pi over 30 as the number between the two. And then this will be 13 pi over 30. Okay. And then over here, we're going to draw this curve. So we're going to draw this curve. So it starts at negative and passes through 0, positive, and then does like that. So make sure that you have this right arc concavity. It has to be shaped correctly. And because the amplitude is 2, it will be from -2 to +2. And then to get the period, you would need, period is this length, which is 8 pi over 15 minus 2 pi over 15, which is 6 pi over 15. And if you divide top and bottom by 3, that's 2 pi over 5. So that's your period. And if you add 6 pi over 15 to 8 pi over 15, you get 14 pi over 15, right? See, 6 pi over 15 is our period, and what I did was I added to this last point this period to figure out where the next period will end. It ends at 14 pi over 15. And if you divide this into 4 equal parts, and then you copy this over here, then you get, okay, so that will be the graph of the two periods. And so let's see, the period, we just found that that's 2 pi over 5. And here's a shortcut. It's really 2 pi divided by this number. If you can remember that, that'll be even quicker. All right, and then find the phase shift. Now, because of the minus, it's not really the first number that you get. So I said this is the period, right? But I said the very first number is the phase shift. Phase shift, however, has to be modified by pi because of the -2. Okay? So whenever you have a negative sign in front, then it affects the phase shift, and it makes the phase shift off by pi. So you end up with 2 pi over 15 added by pi, which is 17 pi over 15. So you have to add the pi to get a new phase shift in the case when you have a negative sign in front.